Yeah, hello everyone. How are you all doing? Welcome to today's session on statistics for data science, where we'll be solving real-world problems. So here I have Dr. Arvind Sheshadri from Hayagriva Software Solutions. So you can now take over the stage.
Yeah, thank you so much, Mr. Vishnu Srinivas sir. So, dear participants, good morning to all present here. So, thank you so much for joining with us for this statistics for data science live training. So, we are Hayagriva Software Solutions, Salem, Tamil Nadu, India. We develop creative products to increase the productivity and to reduce the human efforts. We do offer mobile apps development training, and we develop creative websites, and we do SEO optimization services, web scraping services, data analytics training, and digital marketing consultancy services. And about us is yeah, Hayagriva Software Solutions, Salem, Tamil Nadu, India. We have two different divisions. First one is software development division, and second one is training and placement division. Hayagriva Software Solutions initiated by young engineers and well-experienced professionals in India. We are creating customizable applications according to our clients' requirement. We are expert in web, mobile, and data analytics domains. We are not compromising our clients with the quality and product. Okay, so this we have the clients across India and USA. Then, dear participants, we are providing training and placement model to the students who are pursuing their higher education and looking for a good career. We have the industry experts in different domains for providing a good training to them. Our mission is to deliver the good quality of product for the customer without compromising them. Then our vision is to automate the human process by implementing the technology. So again, I am telling that we are the people of expertise in software development, data analysis, and full stack training. Our team has
Yeah.
more than 5 years of experience in development and training. Then mostly we use tools to create any kind of applications, such as using Flutter and Dart, then mobile apps, Django for web application, Electron in GitHub, and .NET for application, and some more. So with this note, I'm taking privilege to introduce our today's speaker. So he is the man who doesn't need any introduction, okay? Because we all are familiar with Vishnu sir. Okay, sir. Yeah. Then our speaker is Mr. Vishnu Kanduri Srinivas. About him is he completed his BTech in computer science at Dhirubhai Ambani Institute of Information and Communication Technology. He was the Internshala student partner and Internshala certified internship trainer. We are very happy to have you here, sir. And he has done a research internship in image processing and machine learning at RV College of Engineering. He has also completed a machine learning and artificial intelligence internship at Digital Tesseract. He was the top performer during the internship. So congratulations to you, sir. We are very happy to have
Yeah.
you here.
Yeah. Thank you. Thank you.
He is the creator of Data Analytics Guru, one-stop place for every data science and data analytics aspirants. we used to follow his instructions only. He has conducted many quiz programs and he delivered some tutorials and he has vast experience in machine learning projects and he prepared job interview tips in his own YouTube channel. So where he makes videos and conduct live sessions on data science and artificial intelligence. So finally, he has received a merit scholarship from four US universities worth more than 10 lakhs. We are very
Yeah,
happy to have you here, sir.
yeah,
And over to you, sir. Please take up the
yeah,
session.
yeah.
Thank you,
Thanks
sir.
a lot, Dr. Arvind Sheshadri, for the very quick introduction. Okay, so without further ado, we'll get started with the session. Uh, are you able to see my screen here? Just let me know now in the comment section. Okay, so we'll get started. Okay, so when it comes to the types of data that we have, so first, today our topic is statistics for data science. So first we'll understand about the data, then what kind of statistics principles can be applied on different types of data so that we can get the results. So when it comes to types of data, there are mainly two types. One is categorical and the other is numerical. So categorical data represents groups or categories. So if you take car brands, for example, like Audi, BMW, and Mercedes, so they are distinct categories. Now, when it comes to numerical data, there we have two types, discrete and continuous. So when it comes to discrete data, it can be usually counted in a finite matter, while continuous is infinite and it's impossible to count. So one example for discrete type of data is the number of children you want to have. And for continuous, it can be the weight or height of a person. Now, when it comes to levels of measurement as to how we can measure the data that we have, there are two types in that. One is qualitative and the other is quantitative. Under qualitative, we have nominal and ordinal types. So when it comes to nominal level of measurement, so it represents categories that cannot be put in any order. So one very good example is the seasons because a particular order is not required. The seasons like winter, spring, summer, and autumn, they can be put in any order. So that kind of data is known as nominal data. Now, the other qualitative level of measurement is ordinal. So in the case of ordinal, there has to be a particular order in which the values can appear. So let's say you're rating a meal at a restaurant, then it has to be in the order that it's disgusting, unappetizing, neutral, tasty, and delicious. So there has to be a particular order. Now, when it comes to quantitative level of measurement, we have two types. One is interval and the other is ratio. They both actually represent numbers, but ratios have a true zero. So let me explain what is the meaning of true zero. So for example, if you take the temperature in degrees Celsius, so 0 degrees Celsius doesn't actually mean absence of temperature. So that comes under interval level of measurement. For example, if you take temperature measurement in degrees Kelvin, so 0 degree Kelvin actually means that there is an absence of temperature. So in that case, if a particular attribute has the value of zero, then if it's actually means that the value is zero, then it's considered a ratio, as in the case of Kelvin temperature. Yeah. Now let's see how we can represent categorical variables using graphs and tables. So the first type is frequency distribution tables. So here we have each of the category and the frequency of that category. Now, the other type is bar charts, where we can, in the y-axis, we have the absolute frequency, and then in the x-axis, we have the actual category. Now, when it comes to pie charts, they're used when you want to see the proportion of a particular category out of the entire total. So, for example, if you're looking at market share of, let's say, mobile phones or cloud services, then pie charts is a very good way of representation. And the other one is Pareto diagrams, which you can see here. So it's a special type of bar chart where the categories are shown in descending order. So if you see, Audi here has the highest frequency, and that's why it appears first. And then as you go towards the right, the frequency is actually decreased. And then instead of having just the bar chart, we also have a line chart. So this line chart represents cumulative frequency. So here we can see that Audi and Mercedes combined together contribute to around 70% of the total sales. So that is identified by the line chart in the Pareto diagram. Now let's see how you can create these using Excel. So Excel is a very powerful tool for data science and data analytics. Many of them don't realize its actual capabilities. Now in the frequency distribution tables, you can just use the sum function to get the frequency of each category. And then to create a bar chart, we can just go to insert charts and then clustered column or bar chart, because bar chart is also known as a clustered column chart. Now for pie charts, we can just click on insert and then charts and then pie chart. Now let's see how you can make Pareto diagrams, because Pareto diagrams, it's not very simple because it has two different charts in a single plot. Now in the recent versions of Excel, when you go to insert, click on charts, there's an option directly for you to insert a Pareto chart. So let's go through the procedure, what happens when you click on create Pareto chart. So first what happens is, as I've already told you, you need to order in the descending order of frequency. So here, if you can see, the highest is at the first and then a bit lower and then a bit lower. So you will just create a bar chart using the frequency distribution table. So part one is done. And then you need to add another column to that table, which measures cumulative frequency. Now you need to select the bar chart plot area and then you have to right click it. Then you have to choose select series. So now you can select the cumulative frequency column and then click on add. And then there it asks for a series name. So just to differentiate it from the bar chart, that can be given anything. The exact name doesn't matter. And then for series values, you can choose the cells. So just as it asks for the series values, you can just click and drag on the cells of the cumulative frequency, and then you can click on OK. So now you will see two side-by-side bars, but that is not we want, because in the case of Pareto diagram, one is a bar chart and the other is a line chart. So now we have to change the chart type. So you have to select combo there at the top right, and then there in the representation, you need to select the initial categories as clustered column for the first one, because clustered column is nothing but a bar chart. And then for the second series, you need to select line as the chart type. So then you will get the Pareto diagram. So now we have discussed how to deal with categorical variables, right? So let's see how to deal with numerical variables. So first, we'll see how to create a frequency distribution table and then the histogram. Now, frequency distribution tables for numerical variables are a bit different than the categorical variables. So let's say we have numbers from 1 to 101. We divide that into distinct categories of equal or unequal length. The length or width of an interval is up to us. We can choose anything. Now, let's say we have numbers from 1 to 101, and we need to calculate the interval width. So interval width can be calculated as the largest number minus smallest number. So in our case, 101 minus 1 divided by, let's say we want 5 intervals. So 101 minus 1 divided by 5, which is 20. So the width of each interval has to be 20. Now, let's see how we can create this frequency distribution table in Excel. So first, you need to decide the number of intervals that we would like to use. In our case, we have decided it to be 5. Now we need to find the interval width using this formula. And then the first interval will start at the lowest value. So in our case, I had told that our data set contains numbers from 1 to 101. So the lowest value is 1. And then we'll finish the first interval with the lowest value plus the interval width. So that is nothing but 1 plus 20. So 21 is the interval end. Now we can repeat the same procedure for the number of intervals we want to have. So we will repeat the same procedure 5 times here because we need 5 intervals. Now let's see how you can get the frequency. So you need to get the frequency, which means we need to use the countif function. So here you can select the dataset range, and then you can say greater than or equal to the interval start. Now we will try to use variables here because we are not going to apply this formula for each and every cell. Instead, what we'll do is we will apply the formula for just one cell here, let's say the first 2 cells, and then we will just drag and drop 5 times. So it will auto populate. So Excel is smart enough to identify the pattern, and then it will auto populate the values using the formula we have entered for the first cell. Now, if we use countif function, so we will get the count when when the value is actually greater than or equal to 1. And then from that, we subtract greater than 21. So take the frequency of where the value is greater than or equal to 1. From that, you remove the frequency where the values are actually greater than 21. So in that way, we will only get the frequency for values between 1 and 21. Now, we've got the frequency, which is the absolute frequency. If you want to calculate the relative frequency, it's very simple. So it's nothing but 2 divided by the total. So here, if you add 2 plus 4 plus 3 plus 6 plus 5, it's 20. So 2 by 20 is 1 by 10 or 0.1. So that is how you calculate the relative frequency. Now, you can also calculate the cumulative frequency if you want to go a step further. So the first cumulative frequency will be same as the relative frequency. And then each consecutive cumulative frequency will be nothing but the previous cumulative frequency and then the current relative frequency. So you know how the cumulative frequency will look like? It will be 0.1, and then the second will be 0.3, which is nothing but 0.2 plus 0.1. So we are basically accumulating all the values as we proceed down the table. I hope you're getting this. Okay, now let's see how you can create a histogram. So histogram is a very common way to represent numerical data. The width of each bar has to be equal to the width of the interval. So in the previous case, the interval width was 20. So here the bar width will also be 20. Now here, if you can see in the diagram that there is a continuation, which means bars are touching. So where the first bar ends, the second bar begins there. So here, if you can see, the first bar ends at 21 and the second bar begins at 21 here. But here, if you see the parenthesis, it indicates that 21 is not included. So even if we start from 21, we are actually meaning to start from 22. Now, this is very simple. In Excel, it's very easy to create charts. You can just click on insert, go to charts. There you'll get a lot of charts there. You can select the chart that you want. If you're not sure of which kind of chart you want, then you can click on recommended charts. So Excel will recommend few charts based on the data that you have. Now, let's say you insert the histogram, but what happens is, so we actually need 5 intervals or 5 bars, but let's say Excel decides to make 10 bars. Now, how do we change it so that we just get 5 bars? Now, we need to select the x-axis, and then you have to click chart tools, go to format, go to axis options. There'll be an option to select bin width or interval width because both are same. Or if you don't know the width of the bin, you can select the number of bins, that is the number of categories you want. So you can enter the number of bins as 5, or you can enter the interval width as 20. So in either way, you'll be getting the same result of the histogram. Now, let's see what a cross table is. So let's say you have 2 variables, that is the type of investment. So let's say stocks, bonds, real estate, and then the type of investor. So let's say we have 3 investors, investor A, B, and C. Now, let's say we want to identify relationships between these 2 variables. So we can create cross tables. So another name for cross table is nothing but contingency table. They're used to represent categorical variables. So in the rows, we will have the type of investment, and then in the columns, we will have that particular person. So in this case, investor A, B, and C. Now for each of this cell, this is the frequency. So how many times has investor A invested in stocks? So here it's 96 times. Let's take another example for 142. How many times has investor C invested in real estate? 142. Now here you can take the row totals and column totals to get an idea. So if you take the row total here, you'll get what is the total number of times any person has invested in a particular type of investment. Now, if you take the column total, you will get the total number of investments made by a particular person. Now, when you have a cross table, you obviously want to make charts to present it to the stakeholders. A very common way is to represent side-by-side bar charts. Now, I've already told you that bar chart is nothing but a clustered column chart. Again, so you can select all the data, that is, click on the first cell and then just drag it into the last cell. Now you can click on insert, charts, and then select clustered column. Now, since you have selected more than one column of data, Excel will automatically give you a side-by-side bar chart instead of giving you a single bar chart. So Excel is smart enough to do that. Now, let's say we have variables, and one other very important type of plot to identify the relationship is scatter plot. So here you can see the first diagram. It indicates a relationship between the x-axis and y-axis. So let's say we have two numerical variables on the same graph, then we usually consider a scatter plot. Now, let's say we have temperature data and then wind speed data. So what you can do is you can make a scatter plot considering those two columns to get a relationship. That is, you can get to know the trend as to whether is if the temperature is increasing, is wind speed actually increasing, or is it the other way, or is there any no relation at all? Now, you can create the scatter plot by selecting scatter under the chart section. So if the scatter plot turns out to be like this, which is the orange shaded bubbles, then it indicates that there is no pattern actually because it's completely vertical, which means there's no association between the two variables. So if we get this type of result for our data analysis, then we can conclude that there's no relationship between temperature and wind speed. If, on the other hand, if it shows a linear pattern like this, that is a straight line like this. So here you have all these dots, right? So if you try to fit a regression line or a straight line, which is an approximation of all these data points, then you will get a line which is of the form y equals x. So in that way, it indicates that there's a linear correlation between temperature and wind speed. Now, I'm sure you're familiar with mean, median, and mode because these are the very basics of statistics. So I'll just go through once. So mean is just adding all the values divided by the total number of values. You can, in Excel, you can use the average function to get this. And for median, you can use the median function. For mode, because a data can have more than one mode. So Excel gives you two functions. If you do mode.sngl, it will just return one mode. If you do mode.mult, it returns an array with all the modes. So if the data has more than one mode and you're familiar with that, then you need to use this function in Excel to get all the modes. Now, mode is nothing but the value which occurs most frequently. So is it possible to have zero modes? Yes, it is possible. Let's say you have all the unique values and no particular value is occurring more than once. Each value is occurring only once. So in this case, the data set has zero modes. It's also possible to have one mode or multiple modes. Then when it comes to median, it is the midpoint of the ordered data set. So what you do is you select the data, you click on sort, and then you select ascending order. Then the middlemost value is nothing but the median. So you need not do all this procedure. You can just use the median function. So Excel will give you the result. Now let's understand what is skewness. So in Excel, you can use the skew function to calculate skewness. So when you use the skew function on a particular type of data, this is the formula Excel is using to calculate skewness. Now, here in the plot, you can see that it is more inclined towards the right hand side. That is, there is a longer tail towards the right side. So it is not that there is equal on both left and right hand side. It is more on the right hand side and it is less on the left hand side. So there is some kind of asymmetry. So if we get a positive skewness when we use the skew function, then it indicates that most of the outliers are towards the right side. If you get a negative value for skewness, then it indicates that most of the outliers are on the left-hand side. So let's say you get the skew value is positive. So it indicates that there is a longer right tail than the left tail. Now, I'm sure you're also familiar with variance and standard deviation. I'll quickly glimpse over it. So you can calculate sample variance and population variance. So if you just have sample of the data, but not the entire data, then you need to use var.s. So S here stands for the sample variance. Now, when it comes to population variance, let's say you have the entire data, then you can use var.p function. Okay, let's say you need to find the standard deviation, then you can use stdev.s. So if you're not familiar already, standard deviation is nothing but the square root of variance. So when you use each of these formulas in Excel, which I've just told you, Excel is actually going to use these four formulas on the right hand side to calculate it for you. So variance actually indicates what is the overall spread of the data set. And then standard deviation is the square root of variance. Yeah. Now there are two other terms which are very important to identify relationship between variables. One is covariance and the other is correlation. So let's say that you get a covariance of 0. So when you use the covariance function, you get the result as 0. So this tells you that the two variables are independent. That is, there is no relationship between the two variables. If you get a positive value for the covariance, it indicates that they move together, or if one increases, the other also increases. If you get a negative covariance, it indicates that the two variables move in opposite directions. So if variable A is increasing, then variable B actually is decreasing. So that's why the covariance value is negative. And then you can use the sample or population covariance formula depending on your data or the situation you're in. Now, what is the difference between covariance and correlation? So correlation also measures the variability of two variables. That is, if the first variable changes, how is the second variable going to change? So then what's the difference? So correlation is a standardized measure. So covariance can give you the values from minus infinity to plus infinity. So it can be very hard for visualization of what that value actually means. If you're able to standardize it to get a value between -1 and 1, we can be very sure because the interval width is limited. So you can use the correl function, and Excel will standardize covariance and give you the correlation output. Okay, just a second. I will now start off with another thing called hypothesis testing. Let me share my screen here. Yeah. Okay. So hypothesis testing is very important for data science because if you're taking data-driven decisions, then hypothesis testing is very important. So let me get started. So what is a hypothesis? So hypothesis is any idea that you want to test. So it can be a statement. Let's say you have limited evidence. So you're not sure whether that statement is actually correct or not. So using the data that you have, first you collect the data, then you create hypothesis testing. So based on the results of the hypothesis testing, you can be sure as to whether my statement is correct or not. So you're actually making a data-driven decision because you're using data to identify whether this particular statement is correct or not. Now, in hypothesis testing, we have two statements. One is the null hypothesis, and the other is alternative hypothesis. So null hypothesis is the statement that we want to test. So you can think that given our limited evidence and knowledge, this is what we know. Let's say we get more data. Now we want to identify whether this statement still holds true given that particular data. Now, alternative hypothesis is a change or innovation. So this is actually our opinion. Now, what kind of decisions can you take after hypothesis testing? So you can obviously do two things. You can accept the null hypothesis or reject the null hypothesis. When you accept the null hypothesis, it means that there is not enough evidence to support your opinion, which is the alternative hypothesis. But if you reject the null hypothesis, then it means that there is enough proof and evidence that the statement that initially you wanted to test it on is actually correct. Now, let's say we have a two-tailed test. I'll explain you what is a two-tailed test and what is a one-tailed test. Just stay on with me. Now, rejection region is nothing but the lower tails, that is both on the right and left hand side. So if you get the hypothesis testing value as something around the middle or which is near to 0, then you actually accept the null hypothesis. But if you get it very far from 0, either on the right hand side or left hand side, then it falls in the rejection region, which means we have to reject the null hypothesis. Now let's understand what is level of significance. So level of significance is actually the probability of making an error, because if the null hypothesis is true, we need to accept it. If it's false, we need to reject it. But if we reject a null hypothesis that is actually true, it is an error, right? Because we're doing the wrong thing. So it's nothing but level of significance. So it is the probability of making this error. So common significance levels are 0.1, 0.05, and 0.01. So that is 10%, 5%, 1%. Now, if you're testing for a statement where you actually have an equality or inequality symbol, then you need to go for the two-sided or two-tailed test. If you have a statement which considers an equality or inequality sign, so such as greater than, less than, then you need to go with one-tailed test. If you go with two-tailed test, what happens is the significance level is divided into two. So significance level is represented using alpha. Now, in the case of two-tailed test, you have both the right and left-hand side. So the significance level is actually divided by two. So 50% of the significance level will go to the left-hand side, and the other 50% goes to the right-hand side. So if alpha is 0.05, then it's 0.025 on the left and 0.025 on the right. Now, what is p-value? So we have understood significance level. So p-value is the smallest value of alpha, which is the significance level at which we can still reject the null hypothesis. Now, a very important p-value is 0.000. So if you get this p-value, then it indicates that you can reject the null hypothesis at any significance level. That is, every time you get 0.000 as the p-value, that is, you get 3 zeros after the decimal point, then you can be sure that your null hypothesis is actually correct. Now here I've made a table for formula for hypothesis testing. So when should you use a particular formula depending on the kind of data that you have? So let's say you have only one population and you know the population variance, then you need to use the Z statistic. So the variance will be represented by sigma square. So sigma is used to define the standard deviation when population variance is known. So here, if you see in the second row, population variance is unknown here, and for the variance, it's S square. Now you can go through this table. So whoever has filled the registration form, I'll be sending them all these materials and even some Excel files so that they can later practice and get back to me via email or WhatsApp if they have any doubts. So here I've given the formulas for test statistic. So, so what is the decision rule? When do we reject the null? We reject the null only if it's one of these three cases. The first case is if the absolute value of test statistic that we compute using this formula here, if it's greater than the critical value, then you need to reject the null. If the p-value is less than the significance level we have considered, so let's say if you have considered 5% significance level, then alpha is 0.05. And when you compute p-value using a particular statistic here, depending on the population and whether you know the population variance or not, if you get it to be less than the significance level, then you have to reject the null. So I would recommend you to use an online p-value calculator rather than using some other statistics tools or computing them on your own. You can just Google search a p-value calculator and then you'll get it. Okay, now that we have finished some concepts, okay. So Shubhodip Sinha wants me to explain skewness once more. Just a second. I'll just share my screen. Yeah. Yeah, so when you visualize skewness, if you get the plot like this, that is the right tail is longer than the left tail, then it indicates that most of the outliers are towards the right hand side. So when does this happen? You use the skew function on your data, and then let's say you get a positive value for that. It indicates that there is right skewness. That is, more outliers are towards the right hand side than the left hand side. So in the case of a normal distribution, you have equal left and right hand tails. But if the data doesn't actually follow a normal distribution, then you'll get this asymmetry here. Yeah, I'll be sending the PPT, don't worry. If you have registered through the Google form which was sent out, you will surely get it. Okay, now what I'll do is I will get started with the practical examples. So we are done with Just a second. Yeah, so we are done with the concept. Now we'll get into the practical examples. So as to how we can apply these concepts to solve real world problems. Okay, so first I'll be using a practical example related to sales. So let's say our product is about apartments, and then we have the product details such as what's the ID, uh, which building is it, and all the details like that, and also what's the type of property, whether it's sold or not. Now we also have details about customers, that is, who purchased a particular product. We have the customer ID, and then we also have entity as to whether that particular customer is an individual or a business. Then we have name, surname, what's the age, and what is the age interval. So if the age is 19, then that person falls into the interval of age 18 to 25. And what's the year and date of birth, what's the gender, country, state, purpose, and how did they rate the purchase, and then have they taken mortgage to on this property, and how did they get to know about this product, was it through website or an agency or a client. Now let's do some gender analysis. So we need to understand what is the gender distribution in our data set. So for that, you can build a frequency distribution table. So since gender is a categorical variable, that is, it can take on only three values, either male, female, or not applicable. So you have the frequency. As I've already told you, you can get the frequency using the countif function. If you want the relative frequency, it's nothing but the absolute frequency divided by the total. So when I share these Excel sheets with you, and let's say you get a doubt as to how this particular value was computed or which formula was used. So just as you select that particular cell, so this is the formula bar. So here you can see that I've divided D6 by D9. So which is nothing but D6 is the absolute frequency, D9 is the total. So before reaching out to me, I think most of the doubts can be solved by you itself just by selecting the cell and then seeing which formula was used to compute this value. And then since we have very few number of categories, we can use a pie chart to identify or visualize the gender distribution. Now, I've already told you that we have both individuals and firms in our dataset. Firms don't have any age and they are given a value n/a in the dataset. So that's the reason for the countif function, I've used n/a to get how many companies purchase the products. Now here you can see that there are more men than women who purchase properties. Now let's do some location analysis. Now, you might be thinking for location analysis, we can just do a bar chart. So we get how many people are from a particular state in a country, let's say. But if you do a Pareto chart, which has both the bar chart indicating the frequency and the line chart indicating cumulative frequency, it will be very helpful. Let me explain. So here, if you consider a Pareto chart, you can understand that California, Nevada, and Oregon together contribute to 81% of the sales. So let's say you're sending this data to the marketing department and they want to focus on the locations from which they're getting more revenue or more profit. Then they can use this Pareto chart to understand, okay, so let me invest more money for marketing only in these three locations. Now we can find the frequency using the countif function. So you, as I have already told, you need not type this formula for each and every cell. What you do is, so when you hover at the bottom right of the cell, you get a pointer like this, like a compass 4 direction one. Then you can just select it and drag it like this. Now, you know the relative frequency, it's nothing but absolute frequency divided by total and cumulative frequency. So for the first time, it will just be the same. Yeah, I'll be sharing the materials, I've already told you. So cumulative frequency for the first row will be the same as the relative frequency. Now for the next case, it will be 45% plus 6%. So we're actually doing cross addition, then 51%. Then the next one will be 51 plus 4. That is, so the general formula is the previous cumulative frequency and the current relative frequency is the formula as to how you find the cumulative frequency for the entire table. As I've already told you, you can just use this formula for one cell, and then you can just drag and drop to all the rows. Just give me a second. Now, let's say you want to find the cumulative frequency of only the United States. So for that, what you can do is so here you can see that we have separated abroad as none, and there are 86 customers from non-US. So what we can do is we can divide 119 by 267 minus 86. So if you're considering only US, so subtract the non-US frequency from the total frequency, and then you get the denominator, and then you can just drag again. So as I've already told, you can just go to insert chart, and then you can select Pareto chart there. Then you'll get this kind of plot. In this way, you can understand what is the segmentation of clients by state. Now, here, if you see the bar chart, you also get the exact frequency for each state. Example, there are 4 people from Virginia. Let's do some age analysis, okay? Now, since age is a numerical variable, and I've already explained you to construct a frequency distribution table for a numerical variable, you need to divide the entire data set into fixed number of intervals. So the number of intervals is up to you. You can choose 5, 6, 7, or even 10. And then as you choose the number of intervals, the interval width is calculated accordingly, as I've already explained. Now, I've already shown you that in the data set, there's a column with the age interval. So there you'll get the frequency, the relative frequency, and so on. Now you can calculate some metrics to get an understanding of the data set. So you can find mean using average, median using median, mode. Now, since there is only one mode, and I know that, we can use mode.sngl. Then you can also find skewness. So Subodip was having a doubt as to, can you explain skewness again? So since here we have a skewness of 0.24, which is positive, it actually means that there is right skewness, which means there are more outliers towards the right hand side because the value is positive. Okay, just a second. If you have not registered for the materials, I will share the Google form. I've posted a Google form link in the comment section. So if you have not registered and you want the materials, then just register in that form. I've just asked 2 things, name and email address. Okay. Now you can find the variance. So here, observe that I've used var.s because I just have a sample of the data and not the entire data. Then you can also find the standard deviation. Now let's do some plotting, okay? So this is the first graph. It represents the frequency distribution of the variable age. So here, if you can see, the highest frequency is at 0 because I've already told you that firms or companies don't have any age. So here, if you see, there are more number of companies than the number of people who fall into a particular age interval. That is the reason we have the highest frequency for the age 0. Now, the second graph is the histogram, okay? So this is the frequency distribution, and this is the histogram. Now, this histogram is based on interval. So here, 18 to 25, 26 to 35, and so on. So you can just select the data here. You can go to insert chart and then click on histogram there. Now let's identify if there is any relationship between age and price. That is, does age of a person influence the price of the property that person is going to purchase? Now, I've already explained you covariance and correlation are 2 very important metrics to identify the relationship between the 2 variables. We need to use the sample covariance formula. Then we need to use the correlation formula. So here we actually have a negative correlation. So this means, and the value is 0.17. So if age increases, price is actually decreasing a bit. And by what factor is it decreasing? So you can see the factor as 0.17 or 17%. So this is the correlation formula. And then to visualize this, you can use a scatter plot. Yeah, I'm happy that skewness is now clear. Yeah, so for the scatter plot, okay, you can just select the data. So you can just go to example. Let me find the age column. Yeah, it's here. And then find the price column. Just hold control and then click on this. And then you'll select, just drag the bottom right of the cell. Then you'll select the entire data. Then go to insert chart scatter plot. Now here, prices are there for all properties, but ages are only there for individuals. I've already told you that companies don't have the age. So if there's a company, in the age column, there is N/A, which means not applicable. Now, here you can see that the age is actually 0. So you can see few blue points directly on the x-axis because age is in the y-axis and age is 0. So these are the companies. Okay. So I hope this was helpful. Now, what I'll do is I'll go with the next example. Let me stop the screen sharing. Let me take a new example, okay? So now we'll do hypothesis testing as to how you can test a particular statement, that is whether it's correct or not. So here I have the data from a company. You have the name, surname, age, gender, country, ethnicity, and then start date. So when did that person start working in that company? Then which department? What's the position and what's the salary? Now, hypothesis testing, right? So let's say we want to identify whether there is gender gap, or uh, is it that females are being paid less than men, or is there no gender gap, that is the salary a person gets is not dependent on the gender. So since we want to check whether there is gender gap, we will take the null hypothesis as that there is no gender gap. So what this means is the mean value of salary of all the men is equal to mean of salaries of all the women. If that is the null hypothesis, alternative hypothesis will be that the means of men and women are not equal, because alternative hypothesis is always opposite to that of the null hypothesis. Now here, male and female employee samples are independent of each other. Now, if you go to that PDF where I've explained, now since we have independent samples and we don't know the population variance, because for some reason I don't have the data of everyone working in the company. I just have a sample of the data because there are some limitations as to how much data you can gather because there is some confidentiality issues. So since I don't know the population variance, but I'll assume it to be equal, okay? So the sample size is 174. So here, if you can see, if you count the number of rows, there are actually 174 rows. So that is the sample size. Now we want to identify how many women and how many men are there. So there are 98 women and 76 men. And then for all these women, we can use the mean formula to find the average salary. Do the same for men, then we need to find the sample variance because we don't have access to population variance. So for this, what you do is you use the VARPA formula, and then you get the sample variance. Now, since these two are independent samples and we have sample variance for both women and men, so to get a metric which combines both of these sample variances, there is a concept called pooled variance. So the pool variance formula is, so you take a number of women minus 1 into the sample variance of that. So pool variance is nothing but a weighted sample variance. Now degrees of freedom is 172. So degrees of freedom is nothing but how many variables can change in the entire data set. So since the sample size is 4, and then two variables, male and female, are already fixed, So 174 minus 2, 172 is the total number of samples that are free to change. So pooled variance is nothing but 98 minus 1, 97 into this plus 76 minus 1 into this. So you sum both of these and you get the pooled variance. Now we need to use the t-score here. So what is the reason I'm using the t-score? Because we have less number of samples here. That is the reason I'm using a t-statistic. So this is the formula for t-score. So it's nothing but men mean minus women mean minus the population mean. In our case, the population mean is 0 because we are testing here for equality. That is whether the mean of men's salary is same as the mean of the female salary. And we divided it by the square root of pooled variance square divided by number of women plus pooled variance divided by the number of men. So if you use this formula, you get the t-score as 1.27. So here, if you see in the formula bar, I've used the exact same formula. Now the p-value that I get is, so I've already told you to find p-value, you can just Google p-value calculator, and then you'll just click on the first link and then select find p-value using t-score. So there you enter the t-score as 1.27 and then you'll get the p-value as 0.103. Now, the common levels of significance is 0.1, 0.05, and 0.01. So when you consider these three levels of significance, p-value is always greater than these three. So we accept the null. Now here we have 172 degrees of freedom. If degrees of freedom is greater than 50, then students' t distribution will actually become normal distribution. So students' t distribution is nothing but the distribution from which we get the t-score. So you see that I'm using the t-score formula here, right? So this value is actually being brought from the t distribution. Now here, since we're accepting the null, we know that there's no gender gap, okay? Now, okay, now that we have identified that there is no gender gap, but what if the gender gap was hidden in the values? So what can we do that? Now, we can separate the data for employees below the age of 35 and employees above the age of 35. So there are two ways to get these data, that is below 35 and above 35. So what you can do is you can just right click and duplicate the sheet here, and then you can apply a filter. Then you can select age as less than 35 in that particular filter. Then you'll get all the values. So just leave there. Again, duplicate it. That'll create a new sheet. In the filter, this time enter age as greater than 35. Now that we have these two data sets, let's understand if the gender gap is actually hidden in the values, which means just by considering one factor, that is the gender, we're not able to get the complete analysis. So what we'll do is we'll also consider age as another variable. That is, we'll do the analysis for greater than 35 and less than 35 ages. Now, you can repeat the same formula which I've already explained. So you can use the same formulas. So you'll get two different tables, right? One is for below 35 and the other is over 35. You'll get the t-score. Then, so here, just observe. Now this is very, very important. So p-value here is 0.331. If you consider common levels of significance such as 0.1, 0.05, or 0.01, 0.331 is greater than all these three values. So we can accept the null. So we're getting the same result that there's no gender gap. But see what happens when we consider the data set with employees age greater than 35. We get a p-value of 0.026. So let's say we consider the significance level as 5% or 0.05 and 0.026 is less than 0.05. So p-value is less than the significance level. Remember and go back to the slides that I've explained. So if p-value is actually less than the significance level, we must reject the null hypothesis. So what does that mean? If we reject the null hypothesis, we need to accept the alternative hypothesis, which is there is gender gap for over 35 people. Now, Okay, I've identified that there is gender gap, but let's say I want to know, are men earning more or are women earning more? Now, there's another very important key metric here. If the T score is positive, then male earns more. That is, okay, let me get go back. So here in the null hypothesis, the first thing we considered was men and then women. So if t score is actually positive, then we are considering the first value, the first variable as having the highest value. Okay, I hope you all learned a lot. Just a second. I hope you all learned a lot. I hope this was a very informative session. So we are done with the session. Uh, so we covered hypothesis testing, descriptive statistics, and then we also covered few examples as to how we can apply these concepts to get the results that you want. I hope you all learned something. Thanks a lot for attending the session. Just give me some time. I will mail you all the materials. If you have any doubts, you can ask me. Okay. Yeah, okay. I also want to tell you something. So here I actually have a website. So what I've done is I have built a platform for people like you who want to learn data science and statistics. So this is the platform. So the website is dataanalyticsguru.com. So this is the website that I've created. So I've posted a lot of tutorials, data science quizzes, projects, interview questions, and job preparation materials. So let me just show you how is this. Yeah. So here, if you can see, you'll get quality tutorials. So you'll be getting step-by-step tutorials to help you unlock your learning from basic to advanced. And we'll be using a lot of tools like Python, SQL, data science, predictive analytics. So you'll be getting tutorials on all these. And then you'll also be getting industry relevant projects. So to be updated, make sure you visit the website. And here it says enter your email address above to get the data science materials. So if you register here, you will be getting all the updates, all the materials, that is all the tutorials, projects, and quizzes. So we'll be covering all these like Python, MySQL, Jupyter Notebook, Tableau, Excel, TensorFlow, Pandas, Scikit-learn, Keras, Spacy, Apache Spark, and Hadoop. Okay, so let me show you a few tutorials that are already on the website. Okay, so in the comment section, I've posted the link to the website. So go there, register above where it says enter your email address. You will soon be getting a lot of data science materials. Now, when it comes to somebody has asked, yeah, suggest a book for statistics. So I don't have actually read any book for statistics. So what I'll do is I'll do my research and then get back to you via email as to which book you can go through. So here in some tutorials, what I have is, so let's say you're working for a company and then you're the product manager or the project manager, or you're an executive and you want to know if data science is actually right for your company. So I've made a two-part series. Then I'm also giving the data science jobs here. So if you click on this data science jobs in India for September 3, so I've given very clearly what is the company, what's the location, and I've also tried to include a lot of fresher jobs which require no experience or only one experience. So I will provide all the details in a very compact way, so you don't have to go through a lot of websites or very long job descriptions. Let's say you like this, you can just click apply here. Now let's say you go below. In this case, I've also given you email ID. So rather than applying directly on the website, if you email it to the recruiter, there are high chances that that recruiter is going to notice you, because not everybody applies via email, right? So here there are 10 jobs currently. So every day I'll be posting few jobs. So let me show you other materials. Now here I've also told what are the machine learning tools you need to excel at. So scikit-learn, pandas, numpy, and I've also provided an explanation as giving an introduction for that particular tool and how it will be useful and when should you use this particular tool. Okay. The another article is, so here, if anybody is interested in working on project, so here you can see part one, part two, part three, Excel for data analysis to better examine data. So this is an entire project tutorial. I've divided into three series. So let me show you how it looks. I've provided step-by-step procedure as to how you need to do. So here, see that when you use this formula, this should be the output. Otherwise, you're doing something wrong. So I've provided step-by-step details as to which formula you have to use and what should be the procedure. So you can complete a project. So this was part one. You can create you can read part two, part three. So in this way, you'll be completing a project in Excel for data analysis, and you can also include this project in your resume. Now let me go to the quizzes section. Okay, so I've received a lot of fantastic response for the tutorials and quizzes. A lot of them have been thanking me for providing these opportunities. So here currently I have the Pandas data science quiz, data analytics in Excel quiz, SQL. And then since machine learning is a very vast field, so what I've done is divided this into a 7-part series. So here if you see, there are a lot of quizzes. Now, let's say you click on this, it will open the quiz. Okay, let me show you the quiz. Yeah, so this is the beginner's machine learning quiz. So here I've provided some both theoretical and application based quizzes. So you can test your knowledge, and you will also get feedback after you finish the quiz and click on submit here. That is after entering your name and email address. So you will know which questions you got wrong, and then in which categories or areas you want to improve them on, because these will be very helpful if you're preparing for interviews and exams, because you want to be sure that you're perfect in all the requirements for the job, otherwise you'll be rejected. So like this, I have a lot of data science, machine learning quizzes, and very soon I'll be including many other topics such as natural language processing, computer vision, and so on. And if you want to be part of the community, what you can do is you can also like the Facebook page so that you get regular updates. Yeah. Okay. Yeah. When it comes to interview questions, let me actually show you. I have actually uploaded the part one of machine learning interview questions. So see here, useful machine learning interview questions for your job. And for this website and platform, I've received a fantastic response. So here I've explained the question. So it's not that I'm giving some random questions. I'm picking questions which are very important and which have a high chance of being asked in the interview. And then I've also provided the detailed explanation for the answer as to how you need to answer and what kind of points you must include in the answer so that recruiter knows that you have enough knowledge to be hired for this role. So I've also given the formulas, and then I've also given some both theoretical and application based questions. So in the comment sections, I've posted the Facebook page link. So there also I post a lot of data science content and materials. So if you want to be updated and be the first one to get all the latest data science jobs and other quality content, I recommend you to like the Facebook page. Okay. So thanks a lot for attending the session. So very soon you'll be getting all the materials so that you can go through whatever I've taught. You can try hands-on. So if you don't understand as to how I got a particular value, you can just click on that cell and then above in the formula bar, it will show what formula have I used. Okay. So thanks a lot for attending the session once again. I hope it was very helpful. Goodbye, everyone. Yeah, you're most welcome. Thanks a lot. Okay.